Welcome, friends. I'm Professor Andrii Bondarenko, and on this channel, we unpack the power, mechanics, and science behind heavy industrial machinery. I'm glad to be your guide through the engineering marvels that shape our modern technogenic world. Today, we are taking a deep dive into drilling rigs. According to the Cambridge English Dictionary, to drill means to make a deep hole in the ground with a special machine in order to look for minerals. Drilling rig for open mining is a mobile machine equipped with a rock drill used to bore holes in open pit mines, quarries, or surface mining operations. In modern industry, various types of drilling rigs are widely utilized in surface, underground, and underwater mining, as well as in construction operations and other applications. The first mechanized drilling rig for mass industrial deployment was Edwin Drake's steam-powered cable tool drilling rig, designed in 1859 in Pennsylvania, US. It was this rig that revolutionized the industry, triggering the global oil rush. Prior to the 19th century, wells were drilled manually or using animal power. Colonel Edwin Drake was the first to combine cable tool percussion drilling with a steam engine. Well drilling is widely utilized in mineral exploration as well as in extraction and construction production processes. Full hole drilling is a method where the entire cross-section of the borehole bottom is continuously crushed and removed by a rotating drill bit under axial load, without extracting a core sample. Core drilling is a drilling method that uses a hollow cutting tool to extract a cylindrical sample of rock, soil, or concrete, known as a core, for geological analysis or structural testing. A spur is defined as an artificial cylindrical cavity in rock with a diameter of up to 75 millimeters and a depth of up to 9 meters. A borehole or well is defined as an artificial cylindrical cavity in rock with a diameter greater than 75 millimeters and a depth exceeding 9 meters. Let us consider the general classification of modern drilling machines. Well drilling involves the application of both mechanical and physical rock fragmentation methods. In modern industrial production, mechanical fragmentation methods are widely utilized, including percussion drilling, rotary-percussion drilling, rotary drilling with roller cone bits, rotary drilling with blade bits. Physical fragmentation methods are classified into thermal drilling, explosive drilling, jet drilling, plasma drilling, electrohydraulic drilling, and ultrasonic drilling. In thermal drilling, steams of liquid fuel combined with an oxidizer are directed onto the hard rock bottom, causing rapid heating and subsequent fragmentation of the rock. In explosive drilling, the borehole bottom is subjected to successive multiple explosions to fragment the rock. In jet drilling or hydrojet drilling, the borehole bottom is subjected to high-pressure water jets. This method is primarily applied when drilling through sedimentary rocks. In plasma drilling, a generated plasma stream is directed onto the hard rock bottom, causing the rock formation to heat up and lose its mechanical strength. In ultrasonic drilling, targeted ultrasonic waves are directed onto the rock bottom, accelerating the destruction of the rock mass. Among the physical fragmentation methods presented on these slides, drilling machines utilizing thermal and jet drilling are the most widely adopted. Modern drilling machines widely employ electric, thermal, pneumatic, hydraulic, and combined drives in their operational processes. Modern drilling machines are capable of drilling vertical, inclined, and horizontal boreholes. By purpose, drilling machines are classified into handheld, column-mounted, and telescopic rock drills, jackhammers, and drilling rigs. The general classification of drilling machines is also presented on this slide. It provides a comprehensive analysis of modern drilling machines based on their key technical characteristics. For drilling operations in rock formations of various origins and strength, drilling rigs utilizing mechanical fragmentation methods are the most widely adopted, including cable tool drilling rigs, rotary drilling rigs with roller cone bits, rotary drilling rigs with blade bits, Rotary-Percussion Drilling Rigs, thermomechanical drilling rigs. The layout of a modern cable tool drilling rig is presented on this slide. They are designed for drilling boreholes in medium hard and hard rocks. Rock fragmentation principle of cable tool drilling rigs. Gravity-driven tool impact followed by incremental rotation upon rebonding from the borehole bottom. The layout of a Ukrainian-manufactured rotary drilling rig with the roller cone bits is presented on this slide. These rigs are engineered for drilling boreholes in medium to hard rock formations. Rock fragmentation principle for rotary drilling rigs with roller cone bits. The rock is fractured by the crushing and chipping action of the roller cone teeth as the bit rotates under an axial load against the borehole bottom. This slide displays a modern rotary drilling rig equipped with blade bits, which is frequently utilized in construction operations. These rigs are engineered for drilling boreholes in soft formations, coal seams, and medium hard rocks. Rock fragmentation principle for rotary drilling rigs with blade bits. The rock is fragmented by the shearing and cutting action of the blades as the bit rotates under an axial load against the borehole bottom. The layout of a modern Rotary-Percussion Drilling Rig, commonly deployed for mining and civil engineering works in hard rock, is presented on this slide. These rigs are engineered for drilling boreholes in medium hard and hard rocks. Rock fragmentation principle for Rotary-Percussion Drilling Rigs. The rock is fractured by high-frequency impacts delivered to a continuously rotating bit under an axial load. This slide displays the view of a modern thermal mechanical drilling rig. They are engineered for drilling boreholes in complex geological conditions, featuring highly variable formations of diverse hardness and structures. Rock fragmentation principle of thermal mechanical drilling rigs. The rock is fragmented through the synergetic combination of thermal stress induced by jet heating and mechanical cutting or impact. The world's largest rotary drilling rig, designed for massive infrastructure projects with 520-ton weight and 42-meter mast. It can drill holes up to 7.5 meters in diameter and 190 meters deep. And now let us watch how a rotary drilling rig with roller cone bits operates. Today's topic was dedicated to drilling rigs. I'm Professor Andrii Bondarenko, and on this channel, we unpack the power, mechanics, and science behind heavy industrial machinery. I'm glad to be your guide through the engineering marvels that shape our modern technogenic world. If you enjoyed this video, don't forget to hit that like button, subscribe to the channel, and share your thoughts in the comments below. Have a question about drilling rigs or heavy machinery? Drop it down there. I'll be happy to answer your questions. Thank you for watching, and I'll see you in the next episode as we continue exploring our modern technogenic world.